So we know that energy can exhibit wavelength-like behavior. So remember, electrons can behave as both waves and particles. And so the electromagnetic radiation, that travels through space at the speed of light in a vacuum. So again, we have your gamma rays, your X-rays, ultraviolet rays, visible, infrared, radio waves, and etc. So these are the three different types of movement that we're going to look at. So with molecular movement, we're looking at translational, rotational, and vibrational. So I'm going to go more in terms of like what each one is, just give you visual. So this next part's not in the notes. It's just again give you a visual of what each one is, and I'll give you something to kind of like remember how I stole it from somebody, but it helps remember which one is which. So like the most you'll have to do with this is just like identifying what is transitional, what's rotational, what's vibrational, and like the main components of it. Oh yeah. All right. So we're looking at spectroscopy. So with ultraviolet or visible light radiation, that's the transition of electrons from one energy level to another. So that is our transitional. Whoa, it's misspelled. So that's how we see color. So when we're talking about transitional radiation, that has to do with visible light, ultraviolet light, the transitions of the electrons. That's why it's called transitional. So maybe to the side, transitional has to do with UV and visible light. So kind of like when we did the flame test, when we applied the fire to the flame, when we applied the sample to the flame, we excited the electrons, and the electrons went from the excited state to the ground state, emitting the photon. That's how we see light, that UV radiation. So transitional has to do with the transitions of electrons, whereas infrared radiation has to deal with molecular vibrations. So this, if you take organic chemistry, there's going to be a problem that'll be similar that we'll do in class. That is kind of like a preview to organic chemistry. So kind of prepare you for that. But it kind of allows you to determine the functional groups. So like alcohol, ester groups, ether, all that. So it measures the vibrations of atoms. So again, the vibrations is the transitions in molecular vibration levels. It tells us these certain functional groups. Like this. So this would be like if you take organic chemistry, this is not going to be the last time that you see this or this. So like at certain parts of waves, you'll see certain functional groups. They vibrate a certain way. So again, the vibration has to do with finding functional groups. And then microwave radiation. So think about an actual microwave. When you put something in the microwave, the plate is turning. So like if I can't draw, but it's like turning in this direction. So microwave radiation this rotates molecules, and it gives us information about polarity. So when that occurs, again, the microwaves are striking particles and it causes them to rotate. So then that's how food is heated up. There's some water molecules in our food, and when we turn on the microwave, it's causing those water molecules to vibrate, and it makes our food hot. So there you go. That's how a microwave works. All right, so here's the mnemonic device I'm going to give you. So like imagine a microwave oven with a glass disc inside it. It rotates. Microwave radiation causes the molecule to rotate. Think about your phone. Your phone vibrates. When it's ringing, IR. It's ringing IR, so if it's vibrating, that's infrared radiation. Infrared radiation has to do with vibration. And then last, UV light. If you think about visible light, you look up to see the sun. Now think about the electrons that are jumping up to higher energy levels. So visible or UV radiation causes electrons to jump up. So that's the key idea. You got to know which radiation belongs to, like what is responsible